Okay, for number 9, they're asking you to explain why the domain has to be restricted for when you're looking for the inverse of a quadratic function, but not when you're finding the inverse of a cubic function. The easiest way to explain that is that the square root function is a many to 1, whereas the cube function or cubic function is a 1 to 1. Graph, if you look at the graphs, this one fails the horizontal line test, whereas this one passes the horizontal line test. So those are acceptable explanations for why you have to restrict the domain for the quadratic but not the cubic function. Okay, so first thing we have to do is find the inverse function. So we switch out the f of x, replace it with y. I'm going to write the 0.25 as 1/4. Okay, x cubed. So now I'm going to isolate the x, so that means I have to multiply both sides by the reciprocal of 1/4, which is 4. And so this is a 1 on the right side. So 4y equals x cubed. So now I'm going to take the cubed root of each side. Okay, so now I get cube root of 4y equals x. I switch the x and the y. Okay, and then once y is by itself, change it to function notation. So f inverse of x equals cube root of 4x. So that's what I got for my inverse. So now I'm going to show that it's true. So I'm going to use composition. So f of f inverse of x equals, I'm going to start with f of x, so it's 1/4 blank cubed, and in the blank I'm going to put in cube root of 4x. Okay, so this means that I'm going to get rid of the radical, because the cube root, the cube of a cube root is, you eliminate, the radicals eliminated, so I have 1/4 times 4x. So 1/4 times 4 is 1. So this leaves me with x. Okay, so now I have to do the other direction. F inverse of f of x. So I start off with the inverse function. And in the parentheses, I'm going to write the f of x function. So 1/4 x cubed. 4 times 1/4, remember 4 is 4 over 1, right? So 4 times 1/4 is 1, so that leaves me with cube root of x cubed, which is x. And so f inverse of x is correct, because we got x for both compositions. And I'll just put compositions. Now we're going to graph. Okay, so I transformed the points on f of x, because remember it's 1/4 x cubed. So the points in black right here, these are the reference points. Again, these are the three that the minimum 3, but I would add these for extra measure to make sure you get the right graph. Because y is because a is 1/4 over here, there's a vertical compression by a factor of 1/4. So that means that the y's are getting multiplied by a 1/4. So that's what I'm showing right here. So these are the points already transformed. Notice the x's did not change, only the y's. Okay, so let's go ahead and plot this. This is f of x. So negative, and notice on my graph I skipped a square for every unit just because of the 1/4 to make it easier to graph that. So -2, -2. Oops. -1, -1/4. So that's about here. 0, 0. 1, 1/4. and then 2, 2. So it goes out like this, and like this. So this is f of x. Okay, when you're graphing more than one function on the same coordinate plane, label them. Okay, so it's easier to identify the equations or the graphs. Okay, so for the inverse function, for this one right here, I'm going to use blue. And instead of doing transformations, what I'm going to do is I'm going to just switch the points. So negative 2 is negative 2. That one, you know, when you switch it, it looks the same. And then negative 1, negative 1/4 is negative 1/4, negative 1. So negative 1/4, negative 1 about here. 0, 0 is still 0, 0. 1, 1/4 is 1/4, 1. So that's about right here where the 1 is. And then 2, 2 stays 2, 2. So this one, remember, this is a cube root function, so this one's going to go like this and like this. And then on this side, like that. So that when you draw the line y equals x, that one is your line of symmetry. So when you draw this line, it's always y equals x. That's your line of symmetry. Okay, so you label the blue right here, f inverse of x. Okay, so the 4 steps for finding the inverse. Y equals negative 12x cubed. I'm going to divide by negative 12. So y over negative 12 equals x cubed. I'm going to take, the cube root of each side. And so you have cube root of y over negative 12 equals x. Switch the x and the y. Oops, I didn't switch it, sorry. That should be x. And that should be y. And once y is by itself, you change it to function notation. So f inverse of x equals, you can put the negative outside if you'd like, because the cube root of negative 1 is negative 1. So we could put the negative out here and then just write cube root of x over 12. So that would be the inverse function. So now we're going to show that it is the right answer. So using composition, f of f inverse of x so we start off with f of x, so that's negative 12, and then in parentheses cubed. So in the parentheses I'm going to put in negative cube root of x over 12. So when you take the cube root of a cube function, or the other way around, the cube of a cube root function, you actually eliminate the radical. So this gives you negative 12 times negative x over 12. So the negative times the negative is positive, and the 12 over 12 is 1. So you're left with x. Doing the other direction, oops, I forgot the f. So f of x, that. We're going to put in negative cube root of x over 12. Whoops, sorry. Like that. And in place of the x, I'm going to fill it in with f of x, so this is going to be negative 12 x cubed up here. Okay, so now what do I have? 12 over 12 is 1, and then I can take out this negative outside, and I have a negative outside, so it's positive, so negative times negative is positive, so then that leaves cube root of x cubed, which is x. So f inverse of x is correct because we got x for both compositions. Okay, now we're going to graph. So for this problem, I did include the -2, -8, and the 2, 8, but notice how after the transformation of the a value, which affects the the y, how big that number got and how small that number got. So they're not going to fit on my graph, and that's okay. As long as you have these three, you're good. So -112, I'm counting by 2's, notice, on the axis on both of them. So -112 be here, 0, 0, and 1, -12. So it's off the grid slightly, so it's going to be about here. Okay, so it's going to be a vertical stretch. So it's going to be really hard to see the curve, but it's still there. And there's also a reflection. So it's going to go down. Okay, so this is f of x. For the inverse, f inverse of x, what I'm going to do, just like before, I'm going to just switch the signs, the x and the y. So instead of -112, I'm going to graph 12, -1, if it fits. Let's see, 4, 10, 12. So that'd be about here, right where the x is, 0, 0, and -12, +1. So it'd be about here. Okay? And so you connect your points. It curves down slightly. And this one curves up. Okay, and there's a graph. There's your f inverse of x. Okay, so we're going to find the inverse. So the f of x becomes y. We add 5/6 to both sides. So you get y plus 5/6 equals x cubed. We take the cube root of both sides. And so we have cube root of y plus 5/6 equals x. So once x